you everyone for coming to the World of Concrete. My name is John Porterfield, and if you haven't recognized me, there I am on the cover of Concrete Producer, so we're pretty excited about that opportunity. And I'd like to thank Hanley Wood for having us out here and giving us this great opportunity to share a lot of our research that we've done over the last few years in a term we call green mining. So what is green mining? Well, we've got a little definition here for you. It's green, it's an adjective, tending to preserve the environment, quality, biodegradable, non-polluting. Mining, we know that, the process of working mines. And green mining, though, means to convert the waste product into a co-product, adding enough value to generate positive economics while concurrently preserving the environment. So we had to set some sustainable industry goals, both for mining and for concrete technology. The first goal was to expand concrete technology in construction. We wanted to showcase green mining and concrete technology with the EPA, and we wanted to integrate mine tailings and other waste rock into a viable concrete products. We wanted to protect the water and restore the environment. We wanted to reduce CO2 emissions, and we wanted to gain LEED credits for post-industrial waste. So we've had to do an intense evaluation. We had to go through aggregate testing. We've done testing for block and pavers as well, in precast, in pre-stressed, and pipe and box culverts. And these are just the start of what is possible to use tailings for. What we found is that the Indians used 80 to 100 uses for the buffalo. This is about 5 primary industries here. Just in blocks alone, there are over 4,000 molds that fit in modern day block machinery. So what we did is we set out to find out some answers about why the industry has so much waste and how we can eliminate that and really bring it out of the waste stream. And what we found is that this is actually a buffalo. It looks like a rock, but it's actually a buffalo. It's got a little bit of backbone backstraps, which is the copper and silver right here. And then the rest of the meat of the animal is all this other gray granite. So when you understand that the mining process is a buffalo, it starts to make sense. The green mining is entirely possible, and here's our chance to do it. It's an ongoing research project. We've interviewed over 200 people now, from regulatory agencies to private industry, to those in the cement industry, to manufacturers, to the educators, to everyone we can come in contact with that would have some involvement in helping the mining industry turn itself back on. We'd like to share some of those interviews with you that will kind of encapsulate our experience over the last couple of years of doing our research. And with that, well, this is it. This is what we want to eliminate. This is where we see future job creation, workforce development happening right through the utilization of all the parts of the mining process. The mine of the future wouldn't include this area. Hundreds of acres covered with sand. We'd have a small adit, a small crushing facility, and then the sand's brought down here along with the concentrate to go out to markets and not cover hundreds of acres. Now 9 stories deep here. It's not right to go after other sand and gravel and have all this as a rock resource right here too. But it's this silica sand that will be the basis for future products and the basis of our industry here in Montana is this waste coming from our mining industry. It is still good portions of rock. It's just very fine material that'll be a solid building block of the future, and it's all coming from this sand that was waste. No more. Let's use all parts of the buffalo.
I think it's a fantastic idea that we could combine with industry and use some of this good silica sand in a custom-made concrete block. So I think what Porter Block is trying to do is fantastic. Here we're mining actually almost flat layers that were laid down from an old inland sea that was later mineralized. So that's where the ore is coming from. And most of it's very finely disseminated. That's why we have to grind this material so fine in order to liberate those little copper minerals. This is about 98% silica. So it's very, very clean silica and very, very pure. So by using some of this good silica sand in an industrial concrete block, not only do we have some economics for the concrete block, but we also have the increased capacity in our tailings dam by taking that material out and using it in a concrete block. So very positive.
If, from the mining company point of view, it's I guess a term cradle to grave. Once you have generated a waste product out of it, tailings are for the most part sand, clay. There really isn't much in most mining operations that's a problem. Most everything is a surface area issue. Most bonds are done concurrently, so based on disturbance. So you can diminish their overall cost by diminishing the footprint that's there. So you may permit, as you say, for the worst case scenario, but when you reach to the end, they would only bond for the actual disturbance. So you can diminish their overall cost on a daily basis or monthly basis by diminishing that footprint.
I've worked on a couple of projects worldwide that have been involved in basically what I call the waste equals food idea. And that idea basically is that you take the waste from one product or from one process and you use it as feed, stock, or food material for another product. That mimics nature. That's exactly what nature does, because nature doesn't have waste, and only human beings seem to create the amount of waste that we're dealing with and will be dealing with in the future. The use of mine tailings in a product would be extremely attractive to the green or sustainable industry, because we're already talking about fly ash and looking for fly ash in products such as Portland cement and using recycled aggregate in our concrete mixtures. So having mine tailings be part of that is a perfect marriage.
Well, I'm here at the World Center for Concrete Technology in Alpena, Michigan at the Besser Museum, and here we have all the early artifacts of Besser's block production. I find incredible motivation from two individuals that I've never met, both with the last name Besser. Herman Besser and his invention of the portable block machine, this small hand-made block machine, and Jesse Besser and his vision of moving this block machine into mass production and automating the process and then building the finest school in the world here at the World Center for Concrete Technology. We see this as a great opportunity. This technology, developed about 1910, represents the answer for the mining industry. They have the tools here for green mining. Green mining represents so much more than what the word green means or even what mining means. Mining is a complete process. It's a respect for the earth. It's a respect for the ore that we're going after. It's not a possibility anymore to stockpile waste rock or waste tailings, that all of those are not waste. No one's really embraced that from the mining world, and it's our role that we're taking on to bring this technology of block and precast into the mining world. And hopefully many will follow, that they will be able to see the mining process as a buffalo. Just like the Indians would find 80 to 100 uses for a buffalo, we'll find 80 to 100 uses for mine waste and use that for quality products for our society.
We look forward to the opportunity of working with Porter Block on promoting the natural resources of Montana, and to recover a lot of the waste products and make good use of them, put them back into viable use. And we're fully supportive of the project and look forward to providing both masonry and precast equipment for the production of block, utility vaults, building aqueducts, and reclaiming that material for the state of Montana. So we look forward to that.